All right, we're going to look at in this slideshow how ions are formed and how this relates to forming an ionic bond and writing an ionic formula. All right, so just to recap, this shouldn't be anything too shocking. Opposite, when charges are similar, look at what they do. All right, they repel each other. So I got two negative charges, and they are repelling each other. All right, so like charges repel, opposite charges attract. All right, see that negative? It's following the positive everywhere it goes. Get away from me. But they attract each other. So opposite charges attract, like charges repel. I think that's Coulomb's law. Coulomb's law. All right, so opposite charges attract and stick together, alike charges repel each other. In order to build an ionic compound that sticks together, you need both positive ions and negative ions. Okay, so a positive ion is formed from elements that have, and we already learned this in the first video, that have loose electrons in their outer shell. All right, we talked about already. These already have one in their outer shell. These have two in their outer shell. They're going to hold on to those electrons a lot less because remember that next level they have is filled, and then these have like three, etc. These have a lot less in their outer shell, and we're going to focus just on this side. And so they're going to be they will very easily lose those because they want that next level's filled. All right, so the metals on the periodic table, we're going to focus exclusively on the alkali metal and alkali earth metals, but there's the transition metals, etc. But they are going to become positive ions. Remember, because they're losing an electron. Remember, an electron is negative. All right, I talked about this in the last one with sodium. Sodium will have, once it loses an electron, once another element will come by and take it, it has more positives than it has negatives. So, because electrons are negative. All right, so all metals are going to be your positive ions. They'll be your, and then the word we used there was cation. Remember, cats, if you like cats, it's positive. I hate cats, so you got to come up with a better way to say that. But positive ions is a cation. Your negative ions are going to be on the right-hand side of the periodic table. All right, we're going to focus on group 17 here and group 16. Remember, group 18, you're like, why is that not highlighted? That's obviously a non-metal. Those are gases. Remember, those already have a full outer shell. Those are the cool guys that everybody wants to be like. All right, so they're going to have negative ions. They have a much stronger pull. It's called electron affinity. They have a much stronger pull on electrons than elements down here. These have a much higher ionization energy where they're going to give up their electron. These have a much stronger pull toward electrons. That's why these don't occur in nature because they react. They're so reactive, and when they come into contact with something, they immediately want to react and they want to get rid of their electron and react. So metals are going to form your positive ions, your cations. Non-metals are going to form your negative ions, your anions. All right, we learned that again, so we'll recap that. And so, since we said positive and negative attracts, our ionic bonds are going to occur between a metal and a non-metal. So that's going to be an easy tip. All right, if I ask you what type of bond is this, is it a ionic or covalent? All right, well, I'm only going to focus on these two groups and these two groups over here. All right, so if you have to jump the periodic table, if I say is potassium and oxygen, what type of bond would that be? Well, potassium would be like located here. Oxygen is here, so if you got to jump the periodic table, if you got to go from one side of the periodic table to the other, well, it's going to be ionic bond because your metals are over here, your non-metals are on the far right. All right, and then the next type we'll talk about is covalent bond. Those are on the same side of the periodic, just two non-metals. So that'll be easy to figure out. All right, so here we're going to look at sodium and chlorine. Chlorine atoms have a strong attraction for electrons. All right, that's that electron affinity. All right, they really want to have electrons because they're so close to having a full outer shell. They only need one more. All right, they're in group 17. They got 7 in their outer shell. We learned in the last notes that 8 is a complete outer shell. Sodium only has 1 to lose, and then it will have a full outer shell. The whole point of bonding is to get that full outer shell. So an electron gets ripped from the sodium atom, turning it into a positive ion. The chlorine It becomes a negatively charged ion, and it's called chloride. All right, so that electron gets transferred, and this is what happened. That next layer makes the chlorine gets larger. The two atoms become oppositely charged. They're ions, and they're oppositely charged. So not only is there a transfer of electrons, but since they're oppositely charged, they attract. All right, because that opposite attraction forms a bond. All right, and that's called an ionic bond. All right, so ionic bonding occurs when the two elements involved, there could be more than that, but when they become ions, when there's a transfer of electrons, one becomes positively charged, metal, the non-metal becomes negatively charged, and those opposite charges attract. Process you saw simplification. We'll look at this a little bit better. All right, each chlorine reaction. Let's see. Here we go. So they transfer those electrons, and they react with one another. All right. The end result: positive ion, negative ion. They bond together. Remember, opposite charges attract. Positive ion will attract to negative ions, etc. nearby. So watch the form they make. All right. So when they bond, because remember, it's never just 1-to-1. That tells you the ratio when we talk about writing a bond. All right, and so when this bond forms, not only is it a positive, does the positive sodium attract to the other negative chlorine, but then it also is going to attract the other negative chlorines and the other positive, and then the positive, other positive will attract the other chlorine. So it's going to create like this staggered structure, because it's going to attract all the positive around it. So when it does this, watch, here we go. They're all going to rearrange themselves to create like this lattice structure. All right, where the positive will be surrounded by the negatives because they attract. The positive is surrounded by the negatives, and the negative surrounded by the positives. All right, so that's the ionic crystal that is going to be created. This three-dimensional crystal shape is going to be created. We'll look at salt. We'll look at what that looks like under the microscope, and we'll be able to kind of see what this kind of compound, what it looks like under the. All right, so to give you a better clue, look, it looks, it's like this three-dimensional lattice structure where a negative is surrounded by positives and the positive is surrounded by negatives. All right, so this ionic bond is formed, but when ionic bonds form, this is the kind of structure that it creates because the positive ion is going to attract the negative ends, and you can see it's surrounded. Anywhere I flip it, the positive is surrounded by the negatives, and the negative is surrounded by the positives, the positive ends. Whee! I have too much fun flipping that around. Alright, so instead of we call that an ionic crystal. A molecule will be something we call, when we talk about covalent bonding, our molecules are forming. But that's called an ionic crystal because there's no clear. And so how we would write this, there are 3 sodium atoms and there are 1 chlorine atom. So we're going to talk about writing ionic bonds in a minute. So it's 3 positives and 3 negative ions. So it's a 1-to-1 ratio. All right, so since there's 1 sodium for every 1 chlorine, it would just be a 1-to-1 ratio. So the way you would write that would be Na. Remember, you don't write the subscript 1, Cl1. So for every 1, what that's saying is that for every 1 sodium atom, there is 1 chlorine atom. All right. And so when we talk about writing ionic bonds, when we talk about writing ionic formulas, which we'll get into, all right, that's the ratio of elements. It's not the total number. That's important. All right, it's the ratio. All right, doesn't mean there's just 1 sodium bonds with 1 chlorine and that creates all the. Obviously, atoms are very, very small. So there's millions and millions of atoms that we're talking about that are creating this bond. All right, but not everything's a 1-to-1. So for example, you have calcium and fluorine. All right, so you can see there's 1, 2, 3, 4. There's 4 to 1, 2. I mean, if you go through and count it all, I'm not gonna. I don't know how many there actually are, but I know that. Or I guess I can go through and this. There looks like there's 4 calcium and 8 chlorine, or fluorine, excuse me. 1, 2, 3, 4, 5, 6, 7, 8. All right. So our ratio there would be, for every 1 calcium, there are 2 fluorine. All right, so that's going to be our answer there. There's 2 fluorine. All right, so for every 1 calcium, there are 2 fluorine atoms. So we'll talk about how to write that. So it has a 1 to 2 ratio. You can see the structure still is very similar, that crystalline structure. All right, so how ions form, why they stick together. We're going to talk more about how to write a formula. We're going to talk about using the oxidation numbers to help write that formula. All right, we'll stop there. All right, so ionic bond, recapping, occurs between a metal and a nonmetal. It's a transferring of electrons where the opposite charges attract, and then they create that crystalline ionic structure.